Hi there. A question that has come up a lot on the forum and during office hours is exactly what I mean by right choices when it comes to non-determinism. And indeed, this is one of the most confusing things about non-determinism when you first see it. So in this video, I'm going to hope to clarify exactly what it means when I say that the NFA always makes the right choices. So consider this language that I've written up here, which is basically all binary strings that aren't the string 0, 0. And suppose that I asked you, for whatever reason, to write an NFA accepting this language. Note that it's actually pretty easy to write a DFA accepting this language, but that's not the point of this video. So one common answer might be something along these lines. If you read in a 0, 0, then you reach a non-accepting state. Otherwise, everything else is just accepted. This seems plausible if you interpret the phrase right choices as the choices you make so that the string ends up being in the language or not in the language. So for example, if I look at the string 0, 0, well, I know that that's not in my target language. It's not in L. And so if I look at how 0, 0 goes in the NFA, it would start here, then read in a 0, and then read in a 0, and end up at a non-accepting state. But this is a big mistake. The NFA doesn't know what the target language is. And so the NFA can't make choices based on whether or not a string should be in the language. Instead, NFAs always make the choices to accept strings. So actually, if you ran this string 0, 0 in this NFA, it's not too hard to see that actually you can make some choices so that 0, 0 ends up in an initial state. If you go 0 and then loop again 0, you end up in the start state, which is also an accepting state. And because it's possible to end up in an accepting state, this NFA accepts 0, 0. It doesn't matter what the question was asking. All that matters is that it could reach an accepting state, and therefore it was accepted. The reason that this is a little confusing is that NFAs don't treat accept and reject in the same way. The principle that makes strings accepted by NFAs doesn't just work if you replace all the accepts by rejects. It's not the same thing. An easy way to remember what an NFA actually does is to think NFAs will always try to accept. NFAs will always choose paths so that the string is accepted. And the only way a string could be rejected is if no matter what path the NFA chooses, it always leads to a reject state. To tie this in with the quantifiers of 165, we say that a string is going to be accepted by an NFA if there exists a path that ends at a final state. On the other hand, a string is rejected by an NFA if, for all paths, those paths end up in a non-final state. So when I say that NFAs always make the right choices, it's not the right choices according to the language that the question is asking you for. It's the right choices according to whether you can reach an accepting state or not. So I hope that clears up some of the confusion. If not, ask a question on the forum or ask me in person, and have a great day.